Welcome to Fall Asleep Channel. Tonight, a quiet journey through light, motion, gravity, and the quiet structure of the visible universe. A calm narrative with interesting facts. If you enjoy peaceful stories like this, you are warmly invited to subscribe and return whenever you need to slow down. Now allow yourself to get comfortable and enjoy quiet and pleasant rest. Let's begin. Light begins its long passage from distant sources, traveling at a constant speed through open space, covering nearly 300,000 kilometers each second, allowing signals from nearby regions to arrive within years, while light from far galaxies requires millions or even billions of years to reach local instruments. This steady pace allows distance to be measured through timing and subtle shift rather than direct travel. Nearby stars appear to move slightly against distant background patterns as the observing position changes across an annual cycle. This effect, known as parallax, allows precise calculation of distance for closer objects. Farther regions require brightness comparison using well-understood reference stars whose intrinsic output remains stable. Faint red shifting of spectral lines reveals how distant systems drift gently away over large-scale expansion, while blue shifting indicates gradual approach in closer neighborhoods. Light carries fingerprints of the elements that produced it, with hydrogen lines appearing in nearly every stellar spectrum, helium signatures emerging strongly in hotter regions, and heavier elements showing narrower patterns formed through layered nuclear processes over long lifetimes. Large clouds of gas and dust gather slowly under gravity, cooling as they compress, forming dense cores where temperature and pressure rise until nuclear fusion begins, igniting new luminous spheres that stabilize once outward radiation balances inward gravitational pull. Surface temperature determines emitted color. Cooler stars glow red, moderate temperatures appear yellow, hotter surfaces shine blue-white. Rotation spreads surface activity into broad bands, while magnetic fields guide plasma motion into looping structures that evolve gradually. Smaller stars burn fuel more slowly, extending stable output for tens of billions of years, while larger stars consume material faster and evolve more quickly through successive stages of expansion and contraction. Stellar winds release atoms into surrounding space, enriching nearby clouds with heavier elements that later become part of new generations of worlds and atmospheres. Light pressure shapes dust distribution around bright sources, clearing inner regions while leaving faint disks farther outward. Planets form within these rotating disks as solid particles collide gently, stick together, and gradually build larger bodies through repeated accumulation. Heavier materials settle closer to heat sources, while lighter gases dominate farther regions. Rotation flattens these disks and aligns orbital paths into shared planes. Angular momentum preserves spacing and timing across developing systems. Gravity maintains predictable motion, faster paths closer inward, slower arcs farther outward. Moons emerge from local debris or capture events, stabilizing rotation and influencing surface motion through tidal interaction. Atmospheres form from volcanic release, captured gas, and chemical processing driven by light exposure. Cloud layers regulate temperature by reflecting and absorbing radiation. Pressure determines how heat circulates vertically and horizontally. Ice lines mark regions where water and other volatiles can remain solid during formation, shaping composition across distance. Small, icy bodies preserve early material far from warmth. Some later travel inward along extended loops, releasing gas and dust when gently warmed, forming visible tails shaped by particle flow rather than direction of motion. Dust grains scatter light, creating faint background glow along orbital planes. Rings around large planets arise from fragmented material held in balance by gravity and nearby satellites. Gaps form through resonance where repeated timing clears narrow lanes. Magnetic fields guide charged particles into radiation belts, producing soft auroral light near polar regions. Telescopes collect faint photons using large mirrors and sensitive detectors. Adaptive optics correct atmospheric distortion. Space-based instruments avoid atmospheric absorption, allowing full spectral measurement from radio waves to gamma radiation. Radio observation reveals cold gas clouds and magnetic structure. Infrared detects warm dust and forming worlds. Visible light shows surface detail and motion. Ultraviolet highlights energetic processes. X-rays trace high-temperature plasma. Timing measurements reveal rotation, orbital period, and mass distribution through small gravitational effects. Gravitational lensing bends light slightly around massive objects, magnifying distant sources and confirming mass presence even when invisible. Cosmic background radiation fills all directions with uniform low-level energy, preserving information about early expansion and density variation. Galaxies organize into spiral disks, elliptical clusters, and irregular groupings. Rotation curves reveal hidden mass influencing motion beyond visible material. Star clusters trace common origin through shared motion and composition. Interstellar gas cycles through collapse, star formation, radiation release, and dispersal, maintaining continuous renewal across long spans. Chemical complexity increases gradually as heavier elements accumulate through repeated stellar generations. Planetary atmospheres evolve slowly through escape, surface interaction, and solar influence. Magnetic shielding preserves gas layers, while radiation drives slow chemistry in upper regions. Tidal interaction shapes rotation and orbital spacing, stabilizing long-term alignment. Measurement techniques refine distance, composition, temperature, velocity, and structure with increasing precision, allowing layered understanding without direct contact. Every observation adds timing and proportion rather than spectacle, reinforcing continuity across scale. As light continues traveling outward, carrying structure and history across immense distance, motion remains gentle, predictable, and open, allowing patterns of formation, circulation, and renewal to unfold quietly without urgency or closure. Far beyond the immediate reach of nearby light sources, the broader structure continues revealing itself through slow accumulation of signals rather than sudden discovery. Groups of stars remain bound together by shared gravity, forming open clusters that disperse gently over hundreds of millions of years, while denser globular collections persist far longer, holding hundreds of thousands of aging suns in spherical balance. Their uniform composition reflects early formation when heavier elements were still scarce. Galactic disks rotate with outer regions moving faster than visible mass alone would suggest, indicating additional unseen material influencing motion across large scales. This hidden component reveals itself only through gravitational effect rather than light emission, maintaining smooth rotation curves rather than chaotic drift. Spiral patterns emerge not as rigid arms but as density waves, regions where gas compresses slightly, triggering new star formation as material passes through, then continuing onward after illumination fades. Central regions often contain compact, massive objects that influence surrounding motion, guiding nearby stars and gas into tight orbits without disrupting wider structure. Jets of energetic particles sometimes extend outward along magnetic alignment, remaining narrow and stable across immense distance. Interstellar space is not empty. Thin gas and dust fill the gaps between stars, absorbing and scattering light, creating dark lanes against bright backgrounds. Molecular clouds within these regions remain cold and dense, allowing complex molecules to form on dust-grained surfaces, including water, carbon compounds, and simple organic structures. Ultraviolet radiation alters these molecules gradually, driving slow chemistry rather than rapid reaction. Cosmic rays pass through clouds, ionizing atoms and influencing charge balance at low levels. Supernova remnants expand gently over time, enriching surrounding regions with heavier elements. While shock fronts eventually fade and merge back into diffuse background, distance measurement extends beyond parallax through standard brightness relationships. Variable stars with predictable pulsation periods allow estimation far beyond local neighborhoods. Surface brightness fluctuation techniques compare graininess in unresolved systems, while redshift analysis maps large-scale expansion across the observable universe. Expansion itself does not resemble outward motion through space, but rather uniform stretching of distance between regions, allowing light to travel while wavelengths lengthen gradually. This stretching occurs evenly rather than from a single center, preserving isotropy across observation. Timescales extend far beyond direct experience, with stellar lifetimes ranging from millions to tens of billions of years. Planetary surfaces evolving over similar spans through gradual impact, erosion, and internal activity, galactic rotation completing only a few cycles over the entire age of the universe, yet remaining remarkably stable. Background radiation temperature continues cooling slowly as expansion proceeds, carrying information about early density fluctuations that later shaped structure. Instrumentation continues refining sensitivity, detecting single photons from faint sources, stabilizing mirrors to nanometer precision, synchronizing clocks across observatories to compare arrival times. Networks of detectors operate together to resolve detail beyond individual limits. Data accumulation replaces momentary observation, building clarity through repetition rather than immediacy. Despite immense scale and diversity, the governing principles remain simple: gravity shaping motion, light carrying information, matter responding proportionally to energy input. No region exists in isolation. Every structure participates in a wider exchange of radiation and influence. Cycles repeat at different speeds, yet remain aligned through shared physical rules. As signals continue arriving from deeper distance, and measurement refines structure without exhausting mystery, motion carries forward without acceleration, expansion proceeds without rupture, and the quiet order of the visible universe remains sustained through balance, timing, and continuity, unfolding steadily into further distance where light still travels, information still arrives, and structure continues revealing itself without boundary or final pause. Closer to local regions again, subtle layers of motion continue shaping how nearby systems evolve without drawing attention. Binary stars exchange mass slowly when outer layers expand, transferring material through narrow streams that alter brightness gently rather than abruptly. Orbital timing adjusts through angular momentum exchange, stabilizing separation over long spans. Multiple star systems arrange themselves into hierarchical patterns where inner pairs orbit tightly while outer companions trace wider paths, preserving long-term stability through proportional spacing rather than rigid symmetry. Planetary surfaces respond continuously to incoming radiation. Darker regions absorb more energy and radiate it gradually, while lighter terrain reflects a larger portion back into surrounding space, smoothing temperature contrast and guiding slow migration of frost and dust. Regolith forms through repeated micro-impacts and thermal cycling, creating fine granular layers that alter reflectivity and heat retention in subtle ways. Crater patterns preserve timing history where erosion remains limited, while atmospheres soften surface change through slow chemical interaction and particle exchange. Gas envelopes remain shaped by pressure gradients and rotation. Faster rotation stretches circulation into narrow bands. Slower rotation allows broader cells to form. Cloud altitude reflects temperature and composition. Water-based clouds dominate cooler regions, while methane and ammonia appear farther from strong illumination. Haze layers filter incoming radiation, moderating surface heating and driving slow photochemical processes in upper layers. Natural satellites influence long-term behavior through tidal interaction, stabilizing axial orientation, redistributing rotational energy, and shaping surface motion through gradual flexing. Subsurface oceans remain liquid beneath thick ice shells where internal friction supplies gentle heat, allowing slow circulation of water and dissolved minerals without surface disruption. Orbital resonance between multiple moons preserves spacing and prevents chaotic drift, maintaining predictable timing across extended intervals. Small bodies continue populating shared regions, near stable gravitational balance points, clustering gently where forces cancel, remaining loosely bound yet persistent across millions of cycles. Collisions remain infrequent, allowing fragile structures and layered deposits to persist. When fragments do disperse, they spread thinly rather than concentrating, contributing to background dust and faint light scattering rather than visible accumulation. Radiation pressure influences the smallest grains, nudging them slowly inward or outward depending on size and charge. Magnetic interaction shapes particle paths subtly near active regions, forming faint streams that trace invisible field geometry. These motions recycle material gradually, rather than transporting it rapidly, maintaining equilibrium rather than imbalance. Thermal emission from surfaces reveals internal heat flow, confirming layered structure beneath rock and ice. Conduction transfers energy slowly upward, while convection circulates deeper material at measured pace, preserving long-term stability without surface expression. Radioactive decay continues supplying gentle internal warmth long after formation, sustaining slow geological processes that reshape terrain gradually rather than episodically. Chemical exchange across surfaces and atmospheres proceeds continuously. Ultraviolet radiation alters molecular bonds, forming new compounds that settle or disperse over time. Ionization in upper layers influences electrical balance and particle movement without visible disturbance. Isotopic ratios record early conditions and long-term processing, preserving chemical memory across immense durations. Measurement techniques refine timing and position with increasing precision. Atomic clocks synchronize signal arrival across large baselines. Interferometry resolves fine detail by combining multiple apertures. Calibration removes atmospheric distortion and instrumental drift, allowing slow change to be detected against steady background. Repeated observation confirms predictability rather than surprise, and through all of these layered processes, continuity remains the defining quality. Motion unfolds without urgency. Energy distributes proportionally. Structure evolves through accumulation rather than disruption. Nearer cycles renew quickly. Farther rhythms extend across long spans, every component remaining aligned within the same quiet field of influence. Where distance stretches time, light carries history, and balance persists without closure, flowing onward into the next gentle interval of unfolding order. Within this extended alignment, small variations continue integrating smoothly into the wider pattern, rather than standing apart. Temperature gradients remain shallow, allowing materials to adjust gradually instead of shifting abruptly. Surfaces warmed during longer illumination cycles release stored energy slowly into surrounding space, maintaining gentle thermal buffering that limits sharp contrast. Fine grains migrate across low-gravity terrain in nearly imperceptible steps, lifted briefly by weak electrostatic forces, settling again where motion diminishes. Over long spans, these movements soften surface contours and subtly alter reflectivity without forming visible boundaries. Porous layers beneath exposed terrain regulate how trapped gases migrate. Narrow channels allow pressure to equalize slowly, preventing sudden release and preserving internal calm. Phase transitions within layered ice occur quietly as temperature and pressure drift slightly, reshaping density and mechanical structure without surface disruption. Internal circulation distributes trace heat upward at measured pace, sustaining layered stability while outer regions remain visually unchanged. Thin atmospheric envelopes remain loosely bound, exchanging molecules gradually with surrounding space, while denser layers retain energy and transport it through broad circulation loops that remain steady and layered. Cloud particles grow, merge, and dissolve continuously, recycling moisture and trace compounds in repeating cycles that resist depletion. Haze layers filter shorter wavelengths, moderating surface heating and guiding slow chemical adjustment in upper regions. Magnetic influence continues shaping charged particle motion into curved paths that reveal invisible geometry rather than visible structure. Radiation regions expand and contract gently with changing particle pressure, remaining proportional and stable. Internal heat migrates outward through layered material, sustaining quiet convection beneath surfaces that appear still, maintaining internal equilibrium through gradual energy transfer. Gravitational organization remains consistent across every scale. Spacing and timing adjust through minute exchanges of momentum, distributing variation evenly rather than allowing accumulation. Resonance relationships maintain predictable alignment across shared paths, preventing gradual drift into irregular spacing. Libration introduces small orientation variation that distributes surface exposure gently over long cycles, preserving balanced illumination rather than fixed extremes. Illumination geometry continues drifting slowly as axial orientation shifts and orbital shape varies slightly, altering seasonal exposure patterns without destabilizing surface balance. Frost deposits migrate in narrow bands along shadow boundaries, forming layered records that accumulate gradually rather than rapidly. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral analysis reveals subtle molecular processing driven by radiation and gentle thermal cycling, reflecting slow adaptation rather than transformation. Background energy from surrounding space provides a constant baseline influence, smoothing extremes and supporting chemical stability across wide distance. Faint material streams link distant regions through gentle exchange, preserving continuity without concentration. Infrared emission traces how different surfaces store and release warmth, confirming smooth thermal response rather than sharp fluctuation. Measurement of motion, brightness, and timing continues refining understanding of internal layering and mass distribution, confirming predictability across countless revolutions. Even as every element remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than concentrating into instability. And as these cycles continue layering quietly upon one another, timing stretches and compresses across distance without breaking alignment. Nearer paths renewing familiar cadence. farther arcs unfolding into long, gentle sweeps, each fragment carried forward within the same steady influence, patterns overlapping softly, change proceeding without urgency, continuity remaining open, and motion flowing onward into another calm interval where balance remains present, persistent, and quietly sustained. As the gradual exchange continues unfolding across this wide field, attention rests naturally on the way information itself travels through space, not as sound or vibration, but as subtle variation carried by light, radio waves, and particle flow. Signals weaken predictably with distance, spreading outward in expanding spheres rather than narrow beams, allowing instruments to reconstruct origin through timing and intensity rather than direct proximity. Polarization reveals magnetic alignment within distant regions, while slight changes in wavelength encode temperature, composition, and motion without physical contact. Even the faintest photons preserve directional memory across immense spans, arriving with consistent timing that supports precise mapping rather than approximation. Thermal radiation emerges from every surface above absolute zero, creating a quiet background glow that reveals internal heat flow and material properties. Colder regions emit longer wavelengths. Warmer regions shift toward shorter bands, allowing layered temperature structure to be inferred without disturbance. Emissivity varies by surface texture and composition, enabling identification of ice, rock, metal, and dust through spectral signature alone. This passive measurement preserves natural equilibrium rather than altering it. Gravitational influence shapes not only motion, but also time measurement through subtle dilation effects near massive objects. Clocks positioned at different gravitational potential tick at slightly different rates, an effect measured precisely and incorporated into navigation systems, preserving alignment across wide distance. Space itself curves gently around mass, bending light paths by small angles that reveal invisible structure through lensing rather than emission. Clusters amplify faint background sources, allowing deeper regions to become visible without increased energy input. Orbital stability depends on proportional spacing and resonance rather than symmetry. Small variations distribute gradually through surrounding paths, preventing accumulation. Chaotic divergence remains rare in well-balanced systems, because energy exchange disperses through multiple channels rather than concentrating. This allows long-term predictability across millions of cycles even as every component remains in motion. Chemical evolution proceeds slowly within cold regions. Surface reactions on dust grains form increasingly complex molecules over long spans. Hydrogen bonding stabilizes water ice, while carbon chains assemble gradually under low-energy radiation. These compounds remain preserved within protected environments until gently released by warming or collision, contributing trace complexity to developing atmospheres and surfaces without rapid transformation. Plasma behavior near active regions remains governed by magnetic confinement rather than pressure alone. Charged particles spiral along field lines, forming coherent streams that redistribute energy smoothly rather than explosively. Wave interactions propagate energy through plasma gradually, damping excess motion and maintaining layered stability across magnetized regions. Rotation influences structural symmetry across many scales, flattening rotating bodies slightly at the poles, shaping cloud band curvature, and aligning debris disks into thin planes. Centrifugal balance distributes mass evenly over long spans, preventing uneven accumulation and preserving predictable geometry. Mass loss from luminous sources occurs steadily rather than episodically. Gentle stellar winds release atoms and ions into surrounding space, shaping extended cavities and pressure boundaries that remain smooth and continuous. This recycled material later integrates into new clouds, continuing the cycle of formation without discrete segmentation. Measurement itself remains non-invasive. Photons arrive without altering source state, allowing passive accumulation of information rather than intervention. Repeated sampling refines accuracy through averaging rather than amplification. Noise decreases as integration time increases, revealing stable patterns beneath transient fluctuation, and so the exchange of energy, motion, and information continues layering quietly across distance. Timing remains consistent, alignment persists, variation disperses naturally into surrounding structure, nearer cycles renew familiar rhythm, farther spans stretch into extended calm, each fragment carried forward within the same steady influence, patterns blending softly, continuity remaining open, and motion flowing onward without boundary, without urgency, and without final resolution. Across these widening scales, coherence continues emerging from the way simple physical limits shape complex behavior without force or emphasis. Energy always follows the path of least resistance, spreading outward until gradients soften and balance returns. Heat migrates from warmer regions toward cooler ones, not as a surge, but as a slow equalization that preserves stability rather than creating contrast. This gradual transfer governs atmospheric circulation, surface temperature patterns, and internal convection alike, linking processes that appear separate through shared thermodynamic rhythm. Momentum remains conserved across every interaction, whether in the quiet drift of dust grains, the steady rotation of large bodies, or the long orbital sweep of distant companions. When motion shifts slightly in one direction, surrounding structure absorbs and redistributes the change, preventing localized buildup and maintaining proportional alignment. Angular momentum exchange regulates spacing and rotation over immense spans, allowing geometry to evolve gently without breaking predictability. Pressure balances operate continuously within gases and plasmas. Density differences drive slow circulation rather than turbulence. Particles diffuse across gradients until concentration equalizes, smoothing structure rather than sharpening boundaries. Ionized regions remain electrically neutral overall, with local charge imbalance resolving rapidly through gentle particle motion rather than discharge. This quiet electrical stability supports long-term consistency across magnetized environments. Radiative transfer proceeds through absorption, emission, and scattering, shaping how energy moves through layered material. Dense regions trap heat longer, releasing it gradually, while sparse regions cool quickly. This difference regulates cloud thickness, ice stability, and surface chemistry without abrupt transition. Optical depth determines how deeply light penetrates, influencing where chemical reactions occur and how temperature gradients form. Matter itself remains structured by atomic forces that scale upward into material behavior. Crystalline ice reflects differently than granular regolith. Metals conduct heat more efficiently than porous rock. Layered sediment stores thermal history and subtle stratification. These material properties influence how each surface responds to illumination and cooling, shaping local balance while remaining integrated into the wider system. Electromagnetic radiation travels in straight paths unless gently curved by gravity or refracted through varying density. Polarization encodes scattering history, revealing particle size and alignment within distant clouds. Doppler shift encodes velocity along the line of sight, allowing motion to be inferred without direct tracking. Intensity variation reveals energy output and surface temperature. each photon carrying multiple layers of information without disturbance. Mechanical stress within solid bodies relaxes slowly through creep rather than fracture when temperature remains low and pressure moderate. This allows shape adjustment over long spans without surface disruption. Ice flows gradually under its own weight, smoothing topography and sealing microfractures. Rock deforms plastically deep below surfaces where pressure rises, redistributing strain without visible change. Time itself becomes an organizing dimension rather than a constraint. Processes unfold according to characteristic scales: milliseconds for atomic transitions, hours for rotation, years for orbital cycles, millions of years for surface reshaping, billions of years for stellar evolution, each layer nested within the next without conflict, allowing complexity to arise through overlap rather than acceleration. Statistical behavior dominates large populations of particles and objects. Individual randomness averages into predictable distribution. Noise diminishes through scale. Order emerges through repetition rather than design. This principle underlies everything from gas pressure to orbital stability, allowing reliability to arise naturally from numbers and time, and so the interconnected field of motion, energy, and structure continues extending calmly across distance and duration, near regions renewing familiar cycles, far regions unfolding slowly across extended spans, every element participating in the same proportional balance, variation dispersing gently, information flowing steadily, alignment remaining intact, motion carrying forward into another open interval where continuity persists without boundary, without urgency, and without final closure. Even as these layered processes continue unfolding, the overall character remains quiet and measured rather than dramatic. Scale expands smoothly from local motion to vast structure without breaking continuity. Nearby systems reveal detail through timing and brightness variation, while distant regions resolve through accumulated signal rather than sharp definition. This gradual reveal supports understanding built on patience rather than immediacy. Stellar groupings drift slowly through their host disks, maintaining relative spacing over millions of years. Differential rotation gently stretches clusters into elongated streams that preserve shared origin signatures in motion and composition. Chemical similarity allows tracing of common formation environments long after visual proximity fades. Metallicity gradients across disks record how successive generations enriched surrounding material, inner regions accumulating heavier elements earlier, outer regions retaining simpler composition longer. Gas dynamics within large rotating structures follow pressure balance and angular momentum conservation. Spiral density waves compress material gently, triggering localized cooling and cloud formation without disrupting overall flow. Shear stabilizes these patterns by distributing energy across wide regions rather than concentrating it. Turbulence remains limited in scale, dissipating gradually into heat rather than cascading into instability. Radiation fields permeate interstellar regions at low intensity, influencing ionization state and molecular chemistry without dominating thermal balance. Shielding by dust grains allows fragile molecules to survive in dense cores, while exposed regions experience slow photodissociation that reshapes composition over long spans. Cosmic microwave background radiation provides a uniform temperature floor, setting baseline conditions for extremely cold environments. Dust grain growth proceeds through gentle collision and electrostatic attraction, forming aggregates that alter scattering behavior and thermal properties. Size distribution influences how light propagates through clouds, affecting temperature gradients and chemical reaction zones. Fragmentation balances growth through rare high-energy impacts. maintaining steady population without runaway accumulation. Mass transfer within interacting systems proceeds conservatively. Angular momentum redistributes between components, widening or tightening orbits gradually. Accretion disks form thin rotating structures where material spirals inward slowly, releasing gravitational energy as mild heating and radiation rather than sudden release. Viscosity within these disks regulates inflow rate, maintaining stability over long spans. Orbital inclination variations remain small in well-aligned systems, preserving thin disk geometry and minimizing collision probability. Mutual perturbations average out through resonance rather than amplify into chaos. Long-term numerical modeling confirms predictable behavior across millions of cycles when proportional spacing remains intact. Planetary magnetospheres interact gently with surrounding particle flow. Bow shocks form where stellar wind pressure balances magnetic resistance, shaping extended cavities that fluctuate slowly with external conditions. Reconnection events redistribute energy in controlled ways, sustaining steady particle circulation rather than accumulation. Surface chemistry evolves through low-energy pathways, adsorption and desorption cycles on mineral grains, slow oxidation and reduction reactions driven by ultraviolet exposure, thermal cycling enabling diffusion through microstructures. These reactions progress quietly, altering composition incrementally rather than visibly. Optical depth within atmospheres controls vertical temperature profiles. Greenhouse gases trap outgoing infrared radiation selectively, while scattering particles redistribute incoming light, maintaining stable stratification and preventing sharp lapse rates. Convection remains gentle when gradients stay shallow, preserving layered structure across long periods. Signal integration across long observation campaigns improves sensitivity beyond individual exposure limits. Stacking data reveals faint patterns embedded within noise. Calibration removes systematic bias, allowing slow trends to emerge clearly. Repeatability validates interpretation rather than novelty, and through this continuous accumulation of subtle exchange, the broader field remains calm, organized by proportion rather than force. Local detail nested naturally within global structure, near cycles renewing steadily, far scales unfolding patiently, every process aligned through shared physical limits, variation dispersing gently, information flowing consistently, motion carrying onward into another open span where continuity remains present, unbroken, and quietly sustained. As this extended balance continues shaping every scale, the impression remains one of gentle coherence rather than accumulation of change. Small adjustments integrate seamlessly into surrounding structure, preventing contrast from becoming disruption. Surfaces continue exchanging energy with their environment through slow radiative flow. Warmer regions releasing excess heat gradually, cooler regions absorbing it steadily, maintaining shallow gradients that stabilize material behavior rather than amplify variation. Microscopic motion never truly pauses. Atoms vibrate within crystal lattices. Molecules diffuse through thin gas layers. Charged particles drift along magnetic geometry, yet these movements remain statistically balanced, producing stable averages rather than visible fluctuation. Diffusion smooths concentration differences over time, preventing localized buildup of heat, charge, or chemical imbalance. This quiet leveling process underlies pressure equilibrium, atmospheric mixing, and long-term compositional stability. Layered structures persist because energy transfer remains limited by conductivity and radiation rather than rapid flow. Rock conducts heat slowly, ice even more gradually, allowing internal warmth to migrate outward over millions of years without surface disruption. This slow transfer sustains mild convection deep below visible layers, redistributing material gently rather than reshaping landscapes abruptly. Porosity influences how gases migrate within these layers, supporting pressure balance through narrow, interconnected pathways that evolve without visible effect. Rotation continues influencing symmetry and circulation across many environments. Centrifugal balance slightly redistributes mass toward equatorial regions, shaping cloud band curvature and surface geometry. Coriolis influence organizes atmospheric flow into broad cells rather than chaotic motion, preserving large-scale stability even as local variation persists. Differential rotation stretches magnetic fields into elongated structures that guide particle motion consistently over long spans. Orbital timing remains predictable because gravitational interaction operates continuously rather than episodically. Each passing alignment introduces tiny exchanges of momentum that distribute gradually through surrounding paths, preventing accumulation of deviation. Resonance locking maintains consistent spacing without rigid fixation, allowing small oscillations that dissipate naturally rather than grow. Libration spreads illumination and thermal exposure gently across surface regions, reducing extremes and supporting uniform aging of materials. Illumination itself remains the primary external driver of surface and atmospheric behavior. Angle of incidence determines heating efficiency. Albedo regulates absorption. Wavelength influences penetration depth and chemical interaction. These variables combine to produce smooth gradients rather than sharp boundaries. Ultraviolet influences surface chemistry and haze formation. Visible light drives thermal balance. Infrared governs cooling and heat redistribution. Each band contributing proportionally rather than dominating. Cosmic particle flux remains low but continuous. Ionization occurs sporadically, influencing electrical balance and molecular reactivity without producing visible disturbance. Shielding by magnetic fields and atmospheric depth moderates penetration, preserving internal stability while allowing slow chemical evolution. Secondary particles dissipate energy gently into surrounding material rather than concentrating it. Large-scale structure remains shaped by cumulative gravity rather than instantaneous interaction. Filamentary arrangements of matter guide gas flow toward denser nodes, while voids expand slowly as material redistributes. Pressure balance between regions equalizes motion over vast distance, preventing runaway collapse or excessive dispersion. This slow rearrangement preserves connectivity across scale rather than fragmenting structure. Measurement itself benefits from this stability. Predictable timing allows long baseline comparison. Repeated sampling improves accuracy, and slow change enables trend detection without ambiguity. Calibration remains anchored by constants that do not drift appreciably across observation timescales, reinforcing continuity rather than novelty. And so the calm integration of motion, energy, and structure continues unfolding without emphasis. Near processes repeating steadily, far processes extending patiently across long spans, every scale nested within the next, variation dispersing into balance, information flowing quietly through light and timing, alignment remaining intact, motion carrying forward into another open interval where continuity persists without boundary, without urgency, and without final resolution. Within this ongoing steadiness, subtle coordination continues linking processes that appear separate yet remain governed by the same physical limits. The way light reflects from a surface influences local temperature, which in turn alters gas density above it. guiding slow circulation that redistributes energy across wider regions. This layered feedback unfolds continuously rather than in steps, allowing systems to remain adaptive without becoming unstable. Minute variations in density shape how soundless pressure waves travel through thin gas layers, equalizing imbalance over distance without turbulence. In colder regions, molecular motion slows further, extending reaction times and preserving delicate structures across long spans. In warmer zones, diffusion accelerates slightly, maintaining uniform composition without sharp gradients. These differences remain proportional, supporting smooth transition rather than contrast. Electrical balance persists quietly within plasma and ionized layers. Free electrons and ions respond instantly to local imbalance, neutralizing charge separation before it amplifies. This rapid micro-response prevents macroscopic instability, allowing magnetized regions to remain structured and predictable. Field-aligned currents distribute energy gently along curved paths, dissipating excess motion gradually into surrounding material. Surface layers continue recording slow environmental history. Micro-layering within ice preserves seasonal illumination timing. Dust grain alignment reflects prevailing magnetic orientation. Mineral weathering indicates long-term radiation exposure. None of these records form suddenly. They accumulate through repetition and quiet consistency rather than event-driven change. Mechanical energy dissipates through friction and internal deformation rather than release. Tidal flexing converts orbital motion into internal warmth gradually, preventing buildup of strain. Rotational slowing occurs through distributed interaction rather than braking. Angular momentum migrates across systems in balanced exchange, maintaining long-term geometry without locking motion into fixed states. Optical scattering within thin atmospheres softens incoming light, reducing direct heating while extending illumination across wider angles. This diffusion limits extreme contrast between illuminated and shaded regions, contributing to thermal buffering that stabilizes surface behavior. Wavelength-dependent scattering also influences color perception and energy penetration depth, shaping chemical activity in upper layers without abrupt boundary formation. In deeper space, particle density remains extremely low, yet cumulative interaction still shapes gradual structure. Even rare collisions exchange momentum and energy over immense spans. Statistical averaging ensures predictability despite individual randomness. This principle underlies gas pressure, radiation background uniformity, and large-scale motion coherence alike. Cosmic expansion continues stretching distance slowly and uniformly, altering wavelength of traveling light without disrupting local gravitational binding. Nearby systems remain dynamically stable while larger scale separation increases gently, preserving layered organization rather than fragmentation. This uniform stretching maintains isotropy across observation rather than directional flow. Thermal equilibrium persists through constant adjustment rather than fixed state. Every region continuously exchanges energy with surroundings, approaching balance asymptotically without reaching absolute stillness. This dynamic equilibrium supports longevity and stability rather than stagnation, allowing gradual adaptation across all scales. Observational continuity benefits from this steady framework. Predictable reference points enable calibration across decades. Repeated measurement reduces uncertainty, and slow evolution allows differentiation between transient noise and meaningful trend. Confidence grows through accumulation rather than novelty, and so the quiet interplay between timing, distance, matter, and energy continues without interruption. Processes layering softly upon one another, near rhythms renewing gently, far spans extending patiently. every element remaining aligned within the same proportional field, variation dispersing naturally, information flowing steadily through light and motion, continuity remaining open, stable, and unfolding onward into another calm interval without boundary or final signal. Through this extended calm, even complexity resolves into simple repeating behavior when observed across enough time. Irregular motion averages into smooth curves. Scattered variation blends into stable distribution. What appears diverse in the moment reveals coherence when viewed across long duration. This principle governs particle motion, atmospheric circulation, orbital timing, and chemical exchange alike, allowing layered systems to remain predictable without rigid uniformity. Energy transfer continues following gradients rather than impulses. Warmer regions radiate outward until difference softens. Cooler regions absorb gradually until balance approaches. Conduction within solid material proceeds, molecule by molecule. Convection circulates deeper layers slowly. Radiation bridges distance without contact, each pathway operating within proportional limits that prevent excess concentration. This distributed flow preserves stability across surface, interior, and surrounding space simultaneously. Matter remains organized by scale-dependent forces. Atomic bonds shape molecular structure. Molecular arrangement defines material behavior. Material properties influence surface response. Surface interaction shapes atmospheric dynamics. Atmospheric flow responds to illumination and rotation. Rotation aligns orbital geometry. Orbital geometry reflects gravitational distribution, every layer nested within the next, forming continuity rather than separation. Low-temperature environments slow chemical kinetics significantly, allowing fragile compounds to persist for extended spans. Adsorption on mineral surfaces stabilizes reactive species, while gradual exposure to radiation alters bonding incrementally rather than abruptly. This slow chemistry contributes trace complexity to dust grains and icy surfaces without triggering rapid transformation in warmer regions. Reaction rates increase modestly, enabling controlled exchange between gas and surface layers. Oxidation, hydration, and photochemical processing proceed gently, forming thin coatings and altered textures that reflect accumulated exposure rather than isolated events. These surface records preserve timing information embedded in molecular arrangement and isotopic balance. Mechanical behavior within solids adapts through creep rather than fracture under low stress, allowing gradual reshaping of internal structure without visible disruption. Layered ice flows imperceptibly under sustained pressure, smoothing topography and redistributing mass over long spans. Crystalline rearrangement reduces internal stress progressively rather than releasing it suddenly. Electromagnetic fields remain continuous rather than segmented. Variations propagate as waves rather than shocks, dissipating energy through dispersion and interaction with surrounding particles. This maintains coherence across magnetized regions and supports stable particle confinement rather than chaotic scattering. Gravitational equilibrium persists because mass distribution evolves slowly. Accretion occurs through incremental collision and adhesion rather than aggregation bursts. Erosion redistributes material thinly rather than carving abruptly. Even large-scale structural change emerges through accumulation of countless small exchanges rather than singular transformation. Temporal layering allows processes with vastly different speeds to coexist harmoniously. Fast atomic transitions average into stable emission lines. Daily rotation cycles integrate into seasonal thermal patterns. Seasonal variation accumulates into geological imprint. Geological change integrates into orbital evolution. Orbital dynamics embed into galactic structure. Galactic motion contributes to cosmic architecture, each scale influencing the next without conflict. Statistical order continues emerging from large populations. Random motion becomes predictable distribution. Noise reduces through averaging. Rare events diminish in influence as sample size increases. This underlies the reliability of pressure laws, radiative transfer, orbital stability, and long-term climate behavior alike. Consistency arises not from control but from number and time. Information carried by light remains persistent, encoding origin conditions long after emission. Polarization traces scattering history. Spectrum reveals composition and temperature. Arrival timing reflects distance and motion, each photon preserving layered detail without disturbance. Observation remains passive accumulation rather than intervention, allowing systems to continue unfolding unchanged while understanding grows gradually, and so the extended fabric of motion, energy, and structure continues weaving itself quietly across distance and duration. Near processes renewing gently, far processes extending patiently, every layer nested into proportional balance, variation dispersing naturally, coherence persisting without rigidity, motion carrying onward into another open span where continuity remains present, stable, and quietly sustained without boundary or final closure. As this steady fabric continues extending across distance and duration, attention rests on how stability emerges not from stillness, but from constant small adjustment. Every region remains slightly in motion. Every exchange remains proportional, preventing accumulation of imbalance. Temperature gradients relax gradually through radiation and conduction, maintaining shallow differences that guide material behavior rather than forcing rapid change. Surfaces warmed by long exposure release stored energy slowly, extending thermal memory across many cycles and softening contrast between illuminated and shaded zones. Fine particles remain suspended in a delicate balance between gravity, radiation pressure, and electrostatic influence, drifting gently along preferred paths rather than scattering randomly. Over long spans, these grains settle into thin layers that modify reflectivity and heat retention, shaping local equilibrium without forming sharp boundaries. Porous structures beneath the surface regulate how gases migrate and equalize pressure, supporting internal stability through narrow, interconnected channels that open and close gradually with temperature variation. Thin gas layers respond softly to illumination change, expanding slightly with warming and contracting as energy dissipates, while denser envelopes maintain broad circulation loops that redistribute heat calmly across altitude and latitude. Condensation and evaporation proceed continuously, recycling trace compounds without depletion. Cloud layers form where temperature and pressure intersect gently, dissolving again as gradients soften, preserving layered organization through repetition rather than control. Magnetic geometry remains quietly present, guiding charged particles along curved trajectories that trace invisible structure through motion rather than shape. Particle populations adjust smoothly to external pressure changes, expanding and relaxing without abrupt transition. Internal heat continues migrating outward through layered material, sustaining slow convection beneath surfaces that remain visually unchanged, maintaining structural equilibrium through gradual energy transfer rather than episodic release. Gravitational influence continues organizing spacing and timing across every scale. Small perturbations distribute naturally through surrounding motion, preventing amplification into irregular drift. Resonance relationships maintain predictable alignment across shared paths, allowing oscillation without instability. Angular momentum exchange proceeds in minute increments, guiding slow evolution of rotation and spacing while preserving long-term coherence. Illumination geometry drifts gently as axial orientation and orbital shape vary slightly, altering seasonal exposure patterns without disrupting thermal balance. Frost deposits migrate in thin bands along shadow boundaries, forming layered records that accumulate over long intervals. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense spans. Spectral measurement reveals subtle molecular processing driven by radiation and slow thermal cycling, reflecting refinement rather than transformation. Background energy from surrounding space provides a constant baseline influence, smoothing extremes and supporting chemical stability across wide distance. Faint material streams connect distant regions through gentle exchange, preserving continuity without concentration. Infrared emission traces how surfaces store and release warmth, confirming smooth thermal response rather than sharp fluctuation. Measurement of motion, brightness, and timing continues refining understanding of internal layering and mass distribution, confirming predictability across countless revolutions. Even as every element remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than concentrating into instability. And within this long continuity, near rhythms renew familiar cadence. Far spans unfold into extended calm, each fragment carried forward within the same steady influence, patterns overlapping softly, change proceeding without urgency, alignment remaining intact. Motion flowing onward into another open interval where balance remains present, quietly sustained, and gently unfolding without boundary or signal. As this extended continuity carries forward without interruption, what remains most apparent is the quiet reliability of natural proportion. Light continues traveling across vast distance at constant speed, preserving timing that allows structure to be mapped through gentle measurement rather than direct contact. Gravity maintains spacing and rhythm without forceful correction, keeping paths smooth and predictable across immense spans. Rotation renews alternating exposure and shadow, guiding gradual warming and cooling that softens daily and seasonal contrast into steady cycles. Atmospheres adjust through layered circulation, redistributing energy and trace compounds calmly rather than abruptly. Magnetic fields curve invisible particle streams into organized regions that evolve slowly and proportionally. Ice migrates along illumination boundaries in thin layered deposits that record long timing without disturbance. Dust lifts, settles, and redistributes quietly in low gravity environments, shaping surface texture through accumulation rather than erosion. Internal warmth migrates outward through layered material at measured pace, sustaining gentle convection beneath surfaces that remain visually unchanged. Spacing and timing continue adjusting through minute exchanges of momentum, maintaining long-term geometry without rigid locking. Resonance relationships preserve openness and prevent gradual crowding. Distant reservoirs of frozen material remain largely unchanged, conserving early composition while releasing occasional travelers along extended loops shaped by gravitational balance. Faint material streams link distant regions through gentle exchange, adding continuity across wide space. Background radiation provides a constant low-level energy presence that smooths extremes and supports chemical stability. Observation continues refining understanding of motion and structure through careful measurement of light and timing, revealing slow evolution rather than sudden change. Every micro-interaction contributes proportionally to the larger pattern, dispersing variation rather than concentrating it. Coherence emerges naturally from alignment and continuous motion rather than control. Nearer paths maintain their quicker cycles. Farther arcs extend into long, sweeping intervals. Distance stretches time without breaking continuity. Patterns overlap softly, one interval blending into the next without boundary or signal. Movement continues without urgency and without conclusion, steady, open, aligned, flowing onward into another calm span of unfolding continuity that remains present, persistent, and quietly sustained across the vast shared field of motion.